Welcome, day two. JEC, JEC World 2026. Joining me is Henry Sodano of Trimer. Is it Trimer Tech or just Trimer?
Trimer Technologies, but we typically just say Trimer.
Okay, all right.
Yeah.
So I am super interested on, I was excited to have you join me. I know we connected last week. You're the CEO
Yes.
of the company. How's the show been so far for you?
It's been very good, yeah. So we had a number of meetings set up, and so it's been progressing well. Trying to get our technology out there. So
Yeah.
I think in the European space, there may be less familiarity with our material system.
Right.
And so it's a really good venue to
Sure.
help spread the word.
Well, we're going to be talking thermosets. So one of the emerging startup technologies here at JEC World comes from Trimer Technologies. Again, you are a startup booster finalist, developing the next generation of thermoset resins that can enable composite manufacturing cycle times under 60 seconds while delivering exceptional thermal and mechanical properties. So we're going to be talking a little bit about that. But before we talk about the technology, Henry, why don't you tell us a little bit about your background?
Yeah, so
You're a professor at Michigan, right?
I'm a professor at the University of Michigan.
Okay.
I teach in the aerospace engineering department.
All right.
And teach the courses focused on composite material analysis.
Okay.
Being a professor, it gives me the freedom to kind of explore different areas, and so I've kind of become more of an expert in organic chemistry as well, and so
Yeah.
I do a lot of the chemistry work. I develop the technology that we're working with, so that's kind of one aspect. And then as a business owner, I've been running companies since 2009 and was running Harp Engineering, which was focused more on the R&D space and developed this chemistry. Mm-hmm. We spun Trimer out of Harp Engineering to focus on the commercialization, scale-up manufacturing of our resin system.
Yeah.
And so we started Trimer in 2018, and we've been working to try to bring it to market. And
where does Trimer? Where does that name? Any particular?
I consider it to be a cross-link. So Trimer is a homopolymerization of three molecules. So but I look at it as a polymer.
Yeah. Right.
Oligomer.
Yeah.
Trimer. So
So I want to talk about the resin technologies, because traditional thermoset composites require long cure times.
Yeah.
So your resin system can achieve cycle times under 60 seconds. That's pretty amazing. How are you able to reach that? I mean, this is...
Yeah, so maybe I'll start with kind of like how we developed what we initially visualized the material as is a bismuth replacement. So we went to the aerospace industry and said, I can manufacture a composite which has the thermal stability of a BMI, actually far exceeding. I can have better mechanical properties, so the best aerospace mechanical properties pretty much that are out there right now. And I can do it at a low price point. And I didn't get a lot of traction, surprisingly. So that's when we started looking at, okay, maybe we can do it another way, and maybe rate and efficient manufacturing is the thing that we can capture interest with. So I brought this little panel here. It's not nothing large, but this is a 3.5 millimeter thick panel that cured in 23 seconds.
Wow.
So we did that. That exceeded the Department of Energy in the U.S.'s 2050 goal for cycle time about 5 years ago. And so you can feel it. It's extremely stiff, very high modulus material. We can get this polymer to have a glass transition temperature close to 400 Celsius.
What is low viscosity?
Yes.
So how centipoise, what are we talking?
Typically, we could vary that. That's quite easy to control, actually.
Yeah.
So we can go lower or higher, but typically our resins are going to be 200 centipoise.
Okay.
So fairly low viscosity. We can drop that down.
Wow.
If you do hot injection, if you're doing RTM and you do preheating, 60 degrees C, that resin will be about 15 centipoise.
Are most of these designed for a closed mold type application, or are we looking also at open?
So we're now compatible with almost every manufacturing process.
Okay.
So this was manufactured with liquid compression molding.
Okay.
So that's a very fast, efficient process. But now we have resins that have working lives of well over a month. So after catalyzation, they will not cure at ambient conditions for over a month.
Okay.
Yet will cure in say 30 seconds.
Yeah.
Right. So that enables a wide variety of manufacturing processes. So now we can do vacuum infusion of very large aerospace structures or large infrastructure applications. It also enables you to do things like sheet molding compound or bulk molding compounds.
Sure.
Where you need that very long working life or you need that long out life to create a product which is shelf stable.
Okay.
So we can do bulk molding compound, sheet molding compound, pre-preg. We've done 3D printing of the resin because it cures so quickly. We can directly print the resin as it cures as it's printed. But then we also do RTM, closed molding operations, liquid compression molding, for instance, or high pressure RTM.
You mentioned obviously aerospace, getting traction there. Any other industries that you're looking to advance this technology into immediately, or?
Yeah, just like we work with almost all manufacturing processes, we work with almost all manufacturing industries as well. So I would say that one of our biggest markets right now is infrastructure. So that could be anything from manhole covers, trench covers, to building materials.
Right.
So we're looking at large-scale infrastructure as well, aerospace, and they're the same materials. So we can use an aerospace-grade material in infrastructure.
That's amazing.
And that's something that really hasn't been brought to market before.
And it's because you talk about going back to low costs. I'm not going to ask you what that means because, but it's affordable, and if it's affordable in aerospace, your price point's obviously higher in certain markets than other markets.
Right.
But you've been able to come about with an affordable technology, or a cost-efficient technology that also delivers some pretty impressive results. I mean, that's pretty amazing. Typically, if you're gaining advantages, and presenting these advantages in one area, then you're going to pay a little more. Right. But not in your case.
No, not in our case. That's my business model. Is that I want to provide value on every front.
Sure.
And so one of the things that I haven't mentioned really is the fire resistance of these materials.
Yeah, I was going to mention.
Yeah. So these materials, without any additives, they're non-halogenated, will not combust, and so we outperform phenolics in fire.
Okay.
So that's kind of one of our major market draws. And say infrastructure is heavily reliant on materials that are non-combustible.
Yeah.
And I guess non-combustible is a technical word that I should use technically. But they have excellent fire resistance.
Yeah.
And so that's one aspect. The other aspect is the bismuth element I mentioned. We can provide superior thermal stability to a bismuth element. Okay. And then the other aspect is the mechanical properties are exceeding most 350F cured epoxies. So we put all of that together in a single package. So if you don't need fire resistance, it's coming with it. If you don't need thermal stability, it's there, right? If you don't need that level of mechanical performance, it's still there.
It's still there,
yeah,
right.
And it's all at a price point that's low. So I'm trying to provide value at every aspect and find reasons that people will not walk away from us.
That's incredible. So one thing I was reading, you stated that this technology already exceeds U.S. Department of Energy's manufacturing targets for 2050. If cycle times like this become widely achievable, I mean, this could change the economics big time. I mean, it's pretty incredible. Yeah, what you guys are doing.
Yeah, part turnover. I think it's one of the most important aspects of a manufacturing process. Right, mold time is dollars. Right. Yeah. So, and that's one way to look at it. Is if you can turn more product, you can turn more profit. The other way to look at it is from an efficiencies perspective, right? A large autoclave, a large tool, providing the heat and the energy that's required to get the temperature up. If you can minimize that by putting more parts through, you have a more efficient process and a more sustainable process.
Henry, thank you so much. This has been, it's truly fascinating. I want to mention Trimer. Trimer-tech.com is the website, and again, people can find you over at the Startup Village.
Yep.
And best of luck later this evening.
Yeah, we're looking for all opportunities. So
absolutely,
if anybody is interested in speaking with us to learn more,
I would love to highlight or actually invite you back on, because I'd really love to follow companies like yours.
Yeah.
I'm sure you'll be at CAMX later this year,
I will be.
and hopefully we can revisit there at the show.
Yeah, and we will have a booth at CAMX.
Oh, great. Good. Very good.
Yes.
Well, thanks again.
Yeah,
Thanks for
thank you
stopping
your
by.
time.